Anytime we are working with functions in our graphing calculator, we might be interested in finding the maximum and minimum values of those functions. Sometimes those minimum and maximum values are what are called absolute minimums and maximums, which is the absolute highest point of the graph and the absolute lowest point of the graph. And sometimes they'll just be relative minimum or maximums, just high points and low points along the way. So for the purposes of this example, I've decided to graph a function 2x cubed plus 3x squared minus 12x plus 3. And when I graph this function, and I did adjust the window a little bit, so if you're trying this at home on your own calculator with 2x cubed plus 3x squared minus 12x plus 3, here are the window settings that I used. And you're welcome to pause the video to set your window so that you'll be looking at the same picture. But when I graph, I get this look. Now, it is clear because this is a cubic function, the highest power in the function is a cube, that the domain of this function is all real numbers. And we can tell by the visual that the range is also all real numbers. This graph is going to continue going up to the right and down to the left, and all of these large absolute value negative numbers and large absolute value positive numbers will work in the function because it is just a cube. There's no disqualifying characteristics for any numbers. So this is where we can expect the interesting things to happen. Obviously, right here at the top of this mountain, we have what's called a relative maximum. That is the highest point of the points that are around it. Same thing with down here, we have a relative minimum. It is the lowest points of the points around it. They are not absolutes. The absolutes are the absolute highest point. There is no absolute highest point. This cubic function goes on forever. There is no absolute lowest point. This function goes on forever. But in the part that we can visualize right here, we have a relative maximum and a relative minimum. Now, we could trace along the curve. So if I press trace and I trace along the curve, I could get down close to where that minimum is. And I could do the same thing with the maximum. But unfortunately with trace, there's no guarantee that you're actually getting to the exact location. We don't know if the exact location is at 0.58851. If I scroll over a little, that looked like it moved down a little bit, but it did start to go back up. So we want some kind of assurance that we're actually getting that absolute lowest point or absolute highest point. And that's where the max and min functions for the calculator come in. So hidden in the trace menu as its secondary option is this calc menu. So if I press second trace, and here's the calc menu, I have a variety of options. Some of the options down here, 6 and 7, a little bit more calculus, a little bit more advanced. These ones are a little bit more of your basic variety. We're going to use, because we were looking at that relative minimum, we're going to use the minimum option, so option number 3. The calculator wants you to set a window to look in. So when it says left bound, all it does is it wants you to move the cursor somewhere to the left of the minimum, somewhere we know is to the left of the minimum. You could be genuinely way out here, so sort of far away from the minimum, just so long as you are to the left of it. Once I press enter, as you imagine, it now wants a right bound. So all I need to do is move my cursor so that I'm somewhere to the right of that bottoming out point. Doesn't really matter where, just somewhere to the right. And I press enter again. And then the calculator will ask you for a guess. The reason the calculator asks you for a guess is because of the mechanics that it uses in the background. It uses a process that requires a first guess for where that minimum is. So when you set your window for it to look in, I picked my left bound and my right bound, I need to tell the calculator not only that left bound and right bound, but also we'll just get it close. So again, I don't know if any of these are the actual minimum or maximum, and frankly, I don't care. I'm going to let the calculator do the work for me. I'm just going to get close, press enter, and the calculator finds my minimum. Now, this brings up an interesting point. As you might imagine, this is not really the minimum. The calculator uses an approximation process when it does this work. So as soon as it hits the value to a certain level of accuracy, it stops. And you might get this kind of weird, strange looking answer. When this happens and you go out to 5 decimal places like this with 0.9, you can just assume that this was supposed to be the number 1 and that this minimum value was at the point 1, -4. If you want to ensure that it wasn't just some weird decimal answer and it actually was 1, -4, you always have the option to go back here, put in 1, and make sure that it comes out as -4. And in this case, it would. That weird, strange answer that we saw isn't going to happen every single time. As the calculator goes through its approximation process, it might give that to you about half of the time. But you just have to be a conscientious user of the minimum maximum feature and know when it's doing that and be aware of that. So for the sake of review and ensuring we understand, let's try the maximum as well. So we'll go back into our second trace menu, and this time we'll choose option number 4, which is the maximum. And they repeat the process again. We're going to arrow over somewhere to the left of the maximum. Again, we don't really necessarily care where, just somewhere to the left. And then we're going to arrow over somewhere to the right of the maximum. And then I'm going to give my best guess close to it. I'm going to press enter, and here we got it exactly. So in this case, we have the maximum value is at x is equal to -2 and y is equal to 23. The minimum maximum tool can be incredibly useful when there are multiple minimums and maximums. So as you progress through your understanding of Algebra 2, geometry, and so on, you're going to start to see graphs that have a lot more bumps and valleys in them, a lot more mountains, hills, and valleys in them. So using the left-bound, right-bound guess, getting it close for the calculator so it can help you find that is a pretty useful tool and will be used in a variety of courses.